everybody. How are you? All right, what are we doing?
You ready to go?
I am.
It's your lab, man.
All right,
Let's get
so
going.
you guys want to check it out? Come on in. We'll show you. We'll give you a behind the scenes look today. Come on in. Let's check this place out. So what have we set up so far, Ben? What have we told our folks?
So we just talked a little bit about, this is where Surface is designed, this is where Surface is prototyped. You guys are working on not just Surface, but on a wide variety of products. And we want to make sure that everybody who's watching the stream understands not just why these are the most productive devices on the planet, but how you build them.
Yeah, cool. We'll show you every detail possible. The building you're in now is actually known as Building 87. It's a building we use to do all our prototyping. We build from the ground up products. We can build end-to-end products in this building. Our engineering team lives in here. Our design team lives in here. They spend days, nights. This building's only been here, I think, for, I don't know the exact time frame, but since Surface started, this is a big deal that we went after. But it's not just Surface in this building. This is the development, if you will, or prototyping of Xbox and HoloLens and Surface itself, and some of the other stuff we work on that we don't always talk about, but it's all in here and we all work on it together. It's this one collaborative space where all the designers come together, the engineers come together, the product makers, the toy makers, all teams come in here to be able to put all the materials together and kind of build these things end to end all the way through the software.
We're really excited. And guys, just remember, we're streaming live, which means this is your chance to ask Panos and everybody else in the lab questions in real time. So it doesn't just need to be the two of us talking. We'll make sure you get a chance as well to talk.
Yeah, if you have questions, ask them. This is that one chance. And Ben's been asking me for a while, can we do it? Can we do it? And, here we are. We're doing it, and we're going to show you some stuff. We got some of our great engineering talent behind these doors. We're going to meet a few of them. We're going to look at some of the machinery, and as you have questions for them, especially, I don't have that much great information, but they have great answers, so we'll get in there and we'll hit it there.
Let's do it.
So you'll see that they're just in the main corridor coming through here. I spend a lot of time in this building. It's the building where I get to put my hands on the product, where the designers put their hands on the product, where Brett Ostrom or Stevie Batish, when there's an issue, we get to look at it. One of the things that we talk about is we want this ability to go end to end at all times, as far as we need to go, from morning to evening, like just push it from an ideation moment all the way through to the product in hand. And once you put that product in your hand, everything kind of changes. You get the feel, you get some of the love off the product, you get the synergy from the product, you get so many different things that come when the physical form comes into play. And then when you turn it on, it goes that much further. The first step in that is we have a bunch of different layers and levels of how detailed we can get on anything we want to build. So let's say there's an idea for a piece part or something small. You guys, let me take you to the 3D printing room first. This is a pretty, I think most people are familiar with 3D printing, so this might feel simplistic, but to understand that in this room, you're going to see, and you can take a shot, where we have a bunch of 3D printers. They work 24/7. A lot of this is confidential in here, but right now you can see we're printing some prototypes for HoloLens. But nothing new here. It's just the current shipping product, but you just see how we continuously work through it. If you come down here,
are those lenses functional? When they come off of a 3D printer like that, are they going to actually work?
I'm not sure.
We're using that for modeling. Yeah.
So this is now you're probably creating a direct model right here, and we didn't actually do anything special for this feat. We're not trying to make it super cool, so right now we have some confidential stuff under here, which we won't talk about, which I'm sure you would want to look under, but we won't. But you see these.
I'll look later.
You see the stuff printing is just, this is the work that has to get done today. You're seeing it real time. I think what you're looking at now is we're just building some models to make sure we have those in hand. Now you can see the depth of these 3D printers. Now, these things can lay down a layer as thin of 1/8 of a human hair. So it tells you how detailed we can get. We want to get down to the micron. So if you're an engineer or a designer and you have a detail on a surface where you really want to understand when we say perfect, you look, every layer can be detailed. As a matter of fact, I'm not sure the spectrum of colors specifically. I think it's over 360,000 colors can be printed on this printer and laid down one layer at a time. And you can kind of see here, this is a sample being built just of the color spectrum that you can lay down with the printer itself, which is cool. So you can imagine the kind of detail we get into as we talk about the products. And you find a problem or an issue, this is more in the creation space where, hey, I have an idea, all right, let's print it. Let's just print your idea. I mean, when you put your mind around an object physically, things change. This isn't just a screen anymore. Emotions come out, the way people think about it come out, the way people debate the product come out, the way people feel it, touch it, kind of put their senses into it. It's pretty neat.
It's really amazing to me that the ability that you have now to take the design process and the iteration process down to a matter of hours as opposed to previously for weeks.
Yeah.
These machines.
Yeah, and I'll explain that. Things have changed dramatically. You'll really see it in the paint room. But we're now in a place where we used to prototype. A prototype may have taken 6 to 8 months at any given time. Maybe 2 months, maybe 4 weeks, 6 weeks, but now we can come up with an idea first thing in the morning, and then by afternoon we've got it printed and we're talking about it.
Tom Warren says hi, so everybody from The Verge, hi.
Hey guys, hey Tom. Hey guys.
All right, what's next?
I think we go look at some fabrics. Let's look at the fabric room. I think we get a lot of questions about how we use fabrics in our products and what it means to us. We just launched the new special edition blade, if you will, the premium finish of the Alcantara. Where do we come up with that? How was that created? So if we just walk you in here, we'll show you the fabric room. Just right through here, just so you see. Cool. This is important. So now you get into, so we were printing plastic in the last room, if you will. Now we're in where we're getting to more materials. Hey Pablo, how are you, man?
I'm good. You?
So good, man. So this is Pablo. He works in this room. Basically, if we come up with a concept for a new, if you will, type cover or anything else we might be building, maybe a palm rest for one of our keyboards, where we really want to put a more touch and feel to the product to bring some elegance, we bring it into this room, and you can kind of see where we take the fabrics, where we learn about them, where we do our testing, where we test with users. We can then build anything we want, and Pablo can do it. And it's in essence one day where we can start building new type covers and work with different materials against different products. It just brings the family together. This is really beautiful. Yeah, so it's kind of cool if you just look at these materials.
Just got some new. These guys just came in, and so I'm actually cutting some samples because we're gonna do some prototyping.
You want to show them how you do it?
Yeah.
Show them how thin you can take a piece of leather like this and what you can do with that material, if you will.
So we it starts out just with the rawhide, comes to us, and we have this wonderful splitter here, and we can go down to 0.2 millimeters.
This will actually like slice it
Slice it.
lengthwise.
Yeah.
So I can
it's
actually
like
thin
a
it down.
horizontal band.
So if you've got something that's really like a thick, full grain piece like that, I can
Yeah, exactly. So if you guys want to see it, I can fire it up for you real quick.
Yeah.
What do you think?
Yeah, let's do
You
it.
like it? All right. Kind of getting it dialed in real quick here, and then we can take a full sheet like we got here, just throw it on through. It just comes out on the other side.
Holy moly.
So that's
amazing. Look at that.
2.3. Started out at about 2 millimeters right here.
The difference.
And so it's it's awesome. It gives us a wide range of capabilities. And we can then use that leather and
Pablo, thank you, man.
Love it. Thanks a lot.
Yeah.
This is amazing.
Thanks for coming by.
Appreciate it.
You guys come on out here. Hey, Ralph.
Hey,
What are you doing, man? You guys know Ralph? This is Ralph Gruen, our creative director.
Hey.
We're doing a live stream right now.
Oh, right.
Yep.
We're just about to paint some stuff. You want to
Let's check it out. Hey, come on in. You want to hang out with us a little bit?
Yeah, let me clear out some stuff. Just wait a second.
All right. So here's what we'll take you to the paint room, and then we're going to move you over here to the CNC room, so you just get a real depth feel of what we do in this building. So we almost went. I'll call 3D printing is pretty advanced. It's pretty cool. We can get to some depths, but we're getting to the next level where what we actually can do on the factory floor, we do here as well. Because we want to do a 24-hour prototyping, we want to do print 24-hour building of products, and we have that ability in this building now, which is kind of cool and a lot of fun. So you saw material, you saw 3D printer. I'm going to take you to the paint room now. This is important. I want to tell you some stories about paint. This isn't about paint. It's not necessarily the hippest word on the planet. That's not what the goal is. But when we want to figure out a color, or we really want to test how something's resonate with our customers, or we want to get feedback from our retailers, and we want to iterate on something where it's either a special edition or a special tint or a special color, we obsess over this stuff. Like when you look at literally the finish on this Surface Book, when we got to Surface Pro 3, we obsessed on how we were going to get to that magnesium finish, to the detail we wanted, where people would grab it, love it, and hold it. And so all that happened here in this room. This is just a priming room, nothing big. You should know that this entire building was basically repurposed around this paint room because the ventilation was so important, basically to keep everybody in a place where they were healthy and we were environmentally conscious, where we did everything, where the ventilation was built through this building. It's kind of a cool room. It's pretty safe. You can see we're working on some of the new S1 priming parts, and so very cool. They're being primed now. And then just working on some finishes. Come on over here. Here's what I love about this and the product making sense. This room is one that has changed for me over the years. I used to work at a different company 16 years ago, and we'd have to color match something. This is a wonderful company called NMB Technologies, but we'd have to color match to make sure we got the right match for our products.
Yeah,
back then.
sure.
So the way to do that was you basically get a GE color match sample. It was a piece of plastic. You take that plastic, you print it, you get that color that you wanted, you'd ship it overseas. Overseas would put it under UV spectrum, they'd analyze it, and they would create the part exactly to your piece. That part would come back to me about 6 weeks later. It would take 6 weeks to match a color. And if it was wrong, that process started all over again, and it's always wrong. I'm never happy. I'm never happy ever. At least that's what I'm told when it comes to the team. Are you painting in there right now?
Yeah, take a look.
You're right. I'll bring you back to this room in just a minute. We'll see what they're working on.
What do we got?
We're painting some Xbox files. Blue.
Okay, you guys got my custom order.
Yeah, that's a little electronic storage. The cool thing is we can paint any color we want. So maybe you want to take an order on that.
That's very cool. Maybe we go back out there where they can hear us. You kind of get an idea of what we do with the paper.
I'll pick that up to you later today.
Okay, that's perfect. Thank you.
Here's one of the things to know that I think is interesting. We basically can make any color that you can think of in this room. If you look over here, these are just a bunch of paint. It's all computerized. Any color that the engineer or design team wants to put or think about on the product, basically it's one touch program mix, and now you have this color come out, and we can finish any type of material we want. Even literally, whether it's fabric or plastic or magnesium or aluminum, you pick, and we can go get that finish right. And by the way, when I said it took 6 weeks before, we can get all this done within minutes. So quickly that if you wanted a part painted right now, we can go create that part for you and get it
I think
back.
that's a fantastic idea. So you said any color you can make.
Any color on the planet.
See, like how he's making it.
Any color on the
So,
planet.
here's
I
the deal,
we
guys.
haven't thought of, but it's probably.
I'm going to put Panos, I'm going to put Ralph to the test here. So, you guys said you can paint something for us, just a matter of minutes. So I'll tell you what, I need some suggestions for what color we want something painted, and then you guys are going to hopefully make it happen.
Yeah, let's do it.
So,
You
let's
do it, Ralph?
let's hook it up. Let's get some colors, guys. I need some stuff on the feed here. We got one for blue.
Blue's easy.
Blue's easy. All right, let me pull up the feed. Let me refresh. I got bright pink. I'd like a bright pink. Yep. We do a bright pink.
Rose quartz.
Rose quartz.
Perfect.
Done.
Yeah, rose quartz sounds perfect. I don't know what color that is, but let's go
We're gonna figure it out. Rose quartz.
Got it?
There you go.
Exactly.
Find the part printed. We'll get it shipped out to whoever this person is. Let's get their name, and we'll get it sent out to them. They can check it out themselves.
Yeah, you bet. So we're gonna pull it off, and I don't see on the feed. It was coming so fast. Thank you for all the comments. We'll find out who had suggested rose quartz. I'm gonna pick it up later in the day. We'll snap some pictures for the world, and then we're gonna get it out to you in just a couple of days. All right. So we got a rose quartz something coming out of there, which is awesome.
We did. Hey, where's Ralphie? Ralph, stick with us, man.
Yeah.
Come with us. Don't stay back. I'd like you to hang out. All right, let's come into this room. I want to talk about what this room is. It's a really impactful room for us. It's been such a blessing to have it. When we were walking through this idea of building this prototyping center about 4 years ago, we were in this place of, what level do we really need to get to be able to work here and at our factories almost simultaneously. So as you know, the details in most of our products are all CNC'd down to a point of, we can get down to 100 microns of detail, and everything's manufactured and fit to order. Every part's unique. I've talked about this before. This is where we actually make that happen. For example, if there's a problem right now at the factory in manufacturing, at the CNC level, and two parts weren't coming together perfectly, or we were marrying something that wasn't marrying correctly, whatever that might have been, we actually can get that data shipped right here. You can look in this room. The CNC machines in this room basically have the same capabilities. They're 5-axis CNC machines, and it's a whole model shop of CNC pool where we now can iterate on the products, and as we are able to create the fixes here, we're able to ship them right to the factory. The factory's ready to implement them right on the line.
So explain what that 5-axis means, because
Yeah.
you obviously know I've had a chance to check these things out before.
Yeah.
But for somebody who's not familiar with this kind of fabrication process,
Yeah.
what does that actually mean?
It's better to look at it. And then Ralph can explain a little bit more, because he used to be a tool maker himself back before we forced him to become a great designer. But this is like a place where you can basically take all 5-axis off a machine and manipulate the part in any direction you want. And we have a bunch of, these things are running full time, and it's probably best just to look at what's happening.
Yeah. So what do we got in here?
So this is the test part where we're showing you the machine. So 3 axes normally, you know, up and down, left and right, back and forth.
Yeah.
3. And in order to do more complex operations, you can see how this part swivels. There's this axis that goes this way and then another rotational point. So we don't need to go and unclamp things and put them in a different fixture. We can make stuff, you know, we clamp stuff in once and it stays in a highly precise way.
I like
so these machines give us huge flexibility in prototyping our different shapes.
And I'm assuming as you're actually milling this piece, are those bits are interchangeable, or is that? Is that fixed?
The little bit that you see there spinning at about 40,000 RPM. That is the extra tool. If the machine needs a different tool, if you look below the green bar there, these blue toolboxes, they open automatically, and the machine grabs another tool.
Did you get that, Sam, in the back there?
Grabs another tool and
So
then that
you'll
goes
automatically
to the
come in, grab a bit, pull it out.
Yeah, it's fully automated.
This is just slightly more advanced than the Dremel I have in my garage.
Yeah, but it's a little bit more. Yeah.
Okay.
Come through. We got a few more parts being cut in. All right. So as you can imagine, so when we create an idea or something comes up, we want to know right away. Or even if it's just a 300 micron difference on one of our parts. Like, this is a big deal. There's always that conversation, like when we obsess about the details. This is the level we're talking about. If we see something keeps us up at night, we basically go right down to the part itself. The engineer is updating the database. The database shows up right here. We're cutting steel and we're looking at it in as much detail as we possibly can, as fast as we can, and we're trying to see if the elegance of what we're trying to create was happening. If that makes sense.
It does.
Any questions that you want to dig in?
So I did get a question about materials. Like, what's the breadth of the materials that you work with? I mean, we saw some of the stuff in the fabric room. We've got this here working out of magnesium.
So the breadth I mean, you go from liquid metal to titanium if you want to go to the future and extremes and what we might be able to do with it, and where Stevie works with these metals and tries to push them to the level that we want to get them to, all the way to magnesium, aluminum, plastics. And so the breadth of materials is not limited. We don't have any limitations there, depending on where we start or what ingot we start from. But we are in this place where we try and push ourselves in materials. Now, you know that the current product line, you'll look at it and we have our magnesium that we build the products with, but there's a bunch of different materials in all those products as well.
Nice. Are those Xbox logos?
Yep, those Xbox logos.
Yeah, and those are Xbox logos, and those are basically printed buttons right now.
It's amazing.
Yeah.
Hey, before you go, what's in the black box?
We can't talk about the black box.
Yeah, come over here. So there's a bunch of stuff in the stream. What about the next products? Like, we're not talking about the next products. We got a lot of working on. We've done some covering up of things that, there's a bunch of future technologies you can imagine, some cool stuff. Stop looking. Pretty cool. Come over here.
We'll look at that one later too. What is that?
Stay up in that part. Come over here.
You said I could sing anything that I wanted to see.
You could ask whatever you want, but I'm just going to pull you away. Come over here. Let me show you the water jet. Pretty cool. So you can see these CNC machines running basically throughout our factory here, where we're going to keep cutting depending on what the part is, basically pushing through. You get a feel, like, as you know, our team also does the mouse and keyboards for the product line.
Wow.
We're working on one of the new keyboards here, which you can see. So this is plastic being CNC'd, so those details are just as important. And so we can now really get to high fidelity models, or if we actually wanted working parts that we use day to day. I have a prototype in my office right now that I'm using. It was built right here, end to end in this building.
Yeah, so every single piece you can just grab it, be assembled, and have effectively a full working model.
We make it sound that easy, but yes, I mean, there's a lot of work that makes that happen, but absolutely.
Man, I sell stuff. I don't engineer stuff. To me, it's magic.
Make
it's
it easy. But the detail, I think the summary of this room is, the details matter, but it's more than that. It's the perfection in those details, making sure that these products are going to be exactly what we intend them to be as they're being built. I have another cool room to show you. This is our water jet room. This is another very, very cool set of products. So this is different. This is when you want to cut through thicker steel, or you want to make the finest precision cut as fast as you possibly can. We actually use 60,000 PSI in the water jet, where it just cuts right through it. You can see these samples here. You can see this is just basically a full slab of, Ralph, is it mag or aluminum? It looks like aluminum.
That's aluminum.
Yeah. So there's a full slab of aluminum, and then you can see how fine it is. I don't know if you can get that shot. I'll put it behind my shirt. You can see how thin that gets. I'm gonna go, that's about 300 microns of thinness, I'm guessing, maybe 250, where you can cut that fine of a line and still have, and you're not actually compromising the structure of the material at all.
Even down to the marble, huh?
Yeah, so, yeah, I guess if you want to do your kitchen counters or whatever, you can do them right here. This is just some marble samples coming out.
I am redoing my kitchen, so I'll send you guys the parts and you guys can make this.
All right, did we pick a name? What's the name we picked? Larry Brazil. So Larry Brazil, I think you're on the feed. Apparently you've got a couple cool comments and questions. So what we did is we took your name. Sorry, I hope that's cool. We fed it to our team here that's basically working on the water jets, and they're making you a nameplate right now. So you can see basically what we've done. Come over here. You can see the cutting process where basically the engineering team put your name, they're writing a nameplate for your jet. And they're taking steel right now, and you'll see the water jet cutting through the steel and making you a nameplate. So I think it's just kind of cool. If you can get up close, we're seeing, it's hard to see the detail. I have no idea what the feed looks like, but hopefully you can get that.
See it?
Can you see it?
That's amazing.
All right. So it's fun.
Larry, congratulations. I think you were the first commenter on the stream. Is that how we picked? Yeah, you're the first commenter. This is what you get for showing up early to one of my live streams, especially with Tanner. We got all sorts of amazing stuff. All right, so now we got wood.
Yeah, so again, somebody asked about materials earlier, which is cool.
Yeah.
Now let's get to the next material. So Ralph will talk about it quite a bit, where he talks about natural materials being used in our products, where the engineers want to use a little bit more organic, where we want to know, like, we don't want fake, we want real, and there's got to be a purpose for everything we do. Of course we work with wood. My son asks me all the time, Dad, do I have to do, like, this wood shop he was in, do I care? Is it important to me? And I'm like, oh my gosh. So I bring him in here and show him, like, look, this is real, man. We use wood to create prototypes. We use wood to help design products. You can kind of see it here, where we use every tool you possibly think of in a wood shop. So it's a little bit like, for those of you in school or wanting to know, or when your kids say, why am I taking wood shop? I'm going to tell you, man, put your hands on things. Creating things from materials as raw as wood, it can be pretty dang cool.
Pretty awesome. So what I'm learning out of this, is you guys could literally remodel my entire kitchen. You can do my marble, you can do my floors.
That's probably right. We don't do that.
Custom mill parts for me. This is way better than Home Depot.
Well, they do better. Yeah, I'm not sure we actually really haven't thought of that.
That was the prize you said you were going to give me on this.
Yeah, you can have that. So
these are beautiful. Absolutely beautiful.
Actually, I should hopefully my wife's not watching this. She is probably going to watch some work, and I'm not really up for it.
Beautiful.
Yeah.
Okay, so we got wood, we got marble, we got water jets. There's a lot of lab left here.
There's a lot. Yeah, let's keep going. We'll keep walking you through. We'll meet a few of the engineers if that's cool with you.
A lot of requests for wood keyboards. Just throwing that off the stream.
All right, wood keyboards. Yeah, they got to feel good too. They got to feel good. They can't just look good. Ergonomics is pretty important. So you're just looking at the bigger beast here. There's a couple of different parts being printed. These are Bittermaster replicas that you're going to find at our factory, where you're wondering, hey, how does CNC work? What happens? We showed you the CNC machines. We showed you the smaller ones. They're easy to see because of the windows. These are a little bigger. These are the 5-axis. You'll find us basically, for example, the Surface Book hinge was prototyped here, I think, every day for a good 6 months, continuously iterating on how we were going to use that dynamic fulcrum and that we talked about at the launch, and the stuff that we ended up putting in that product to bring it to life. Even the edge treatments were all pretty much created here. And if you glance into each of these machines, you'll see the model makers just working on it. So here's the CNC machine kicking off. You can just see a little bit more of the flavor of what it can bring to life. If you come over here, get a better look. Go ahead. Yeah, so here's a hinge that's actually being prototyped right now. It's kind of hard to see it. Sorry, man. But you'll see how the CNC with the water flow right now is cutting into the magnesium and basically working out what is fundamentally the hinge on a Surface Book today.
Pretty amazing.
Yeah.
Look at that.
Yeah. So we had a lot of challenges when we built the Surface Book. The hinge, making a dynamic fulcrum to create the balance on people's laps, and then making sure that those details came together where there wasn't a pinch. These sort of things were iterated in here.
So I had a great question from a guy named Salman, who's one of our followers, who said, at what point do you decide that you're done prototyping and you lock on a design that's ready for production?
Yeah, so we have a series of gates that we go through for the product. The prototyping is an overused word. Prototyping isn't maybe not fair all the time, especially for the engineering teams. We basically create products from 0 to what we call 0.8 ID model. That's the prototyping of what we want the industrial design to be. The problem is it's just the beginning, and prototyping is not fair. We then have phases of our builds. We call them EV, DV. They're different words. They're all buzzwords in our industry. But what happens is we have iterative builds.
Okay. I want to make sure we're not getting.
You want to finish what you're doing? We have these iterative builds, and those builds you can consider prototypes, but they're not. They're actually building of the product at all times until we get it qualified. Now there's trade-offs all the time between industrial design, mechanical engineering, electrical engineering, optics, screen. Everybody's trading off. All teams are working together harmoniously in a way. We try and do it as relentless as we can, but as harmonious as we can, and that product comes together the way we want it.
All right. So, can I pause for just 30 seconds and say something to our retail pros really quick? So, retail pros from Expert Zone, thank you for hanging out. Remember, some of your markets are running additional promotions that are attached to this stream. We said we're going to give you 2 parts of a code for some of those markets, and you're going to be able to enter that into Expert Zone and win some stuff. This is the first part of the code. So, if you're in a market that's participating in the giveaway, this is the first part of the code. We're going to give the second half of the code at the end of the stream. Let's keep going. I'll give that code in a little bit.
So I'm going to introduce you to Robin. She's one of our top talented mechanical engineers in Surface. She's been working on this product line since the beginning. She's going to walk you through basically the process of building a bucket and how she designs it. I think it'd be pretty interesting for the listeners.
Yeah, absolutely.
And then you guys can ask any questions you want of Robin as well. Let's get
All right,
over here. All right, so
Ben Rudolph. Hi.
guys, this is Robin. Robin is one of our, like I said, mechanical engineers. I've already introduced you before I was here. But if you want to just walk them through a little bit of the process of what you're doing here, what I think you're looking at, basically the top side of a book. Is that what this is?
Yes, these.
Yeah, go ahead and take it over.
Yeah, so this first one's a magnesium billet. It's the overall bigger than the X, Y, and Z dimensions. This is what we start off with the top. This is an example of the top of the Surface book.
So before it becomes that, it starts off as like this solid block.
Exactly. And we CNC away through different machines at different stages. Here we can do it all in one machine, but in China, to be more efficient, we do it in
You're gonna have to yell into that mic a little
Sorry.
bit.
We have to do it in multiple machines.
Okay.
So it progresses through different, the vent pattern you start to see forming, and the ledge, the bonding ledge, where we are actually going to put the display to bond onto it. But it still has a really thick floor here. So as you go through the processes, the floor starts to get thinner. And by the time you get even closer to the end, some areas...
I'm going to trade place with you, so
Sure.
I'm not constantly
Yeah,
reaching
sure.
across.
So these swirly patterns that you see here,
Yeah.
those are actually machined down to 0.5 millimeters.
Wow.
The whole product thickness is 7.7 millimeters, but down there you get down to 0.5. The general thickness across the whole thing is 0.8 millimeters. If you go much below 0.5, you start to it starts to have some cosmetic problems. You can start basically like foil at that point. So
Okay.
some of these you can see that the ribs aren't. Some of these are prototypes, and some of these are different stages. Panos had asked me earlier about the challenges, like some of the big challenges that we have.
It's a really interesting question because, like, for a layman like me, going from this to something like that feels
Yeah.
like magic.
Yeah.
And it's obviously way more complex and just like, oh, we just mill it out and now we've got a thing. So, how did you actually tell me a little bit about that? Like, what are the things that made it so hard and made it from this into this?
Yeah, so our biggest drivers in this whole design are weight and thickness, really. We work with the design team to decide how heavy it can be for the display size, how thick it can be, and also center of gravity is really important. Since this Surface book, it goes on the base, and when you use it as a laptop, you don't want, if the center of gravity is too high, you don't want to tip it over, right?
Yeah.
And there's a lot of components that are up here that you don't want them to be heavy up top. They create a bigger moment so that it would even tip even worse or have bad bounce. So we have to be very intentional. It's kind of like a puzzle. We have to be very intentional about where we put components that are different weights throughout the whole system.
I think it's really interesting when you start thinking about products where, like, there's always this kind of like general swirl in the industry of it's got to be thinner and it's got to be lighter. But there's a certain point where lightness and thinness becomes a hindrance to ergonomics, right?
Yeah, with what we're working with, we kind of balance the motherboard and the processor. There's a certain limit to how thick, and thermal solution to how that can be. The processor that we get from Intel is pretty defined thickness, and motherboard thicknesses, there is some variation, but we're talking percentages of microns or millimeters at that point. And you have it can be up to 100 C, the processor can, maybe even hotter in some cases, and it's only say 2 millimeters away from where the customer touches.
Yeah.
And so thermal solution, the stack up to have a display and a motherboard and a processor and a thermal solution and airflow to be able to cool that thermal solution, and then the thickness of the actual chassis. That's where you run into a lot of your thickness limitations. Battery thickness also plays a role. We want the customer to be able to have a long battery life, but we don't want to make the system too heavy, or sometimes we don't even have much room in the system to expand them.
Interesting. So I got a question about the actual metallurgy behind this. About the alloys that are used. Is it I'll put it in quotes, a standard alloy? Is it something that you work with specific providers to create?
Sure. So this is magnesium.
Yeah.
Most laptops, tablets are made with either magnesium or aluminum. Aluminum is 35% heavier. So we want to be able to use the lighter. We do everything we can in here to be as light as possible, all the way down from, sometimes we go for lighter capacitors, and like we were talking about, just taking tiny little speed holes throughout the whole thing. Very intentional with our weight and our thickness. It's a little bit less stiff, so we have to make up for that with ribs that can span across the whole system, the whole chassis here. We also have all of these are bosses where you screw the motherboard into. And the motherboard acts as a stiffening, it stiffens the system a lot. If you take it when it's just magnesium like this, it's actually pretty flexible and can see plenty. As you build it up, it becomes a lot stiffer.
That's interesting. I got a question about milling.
Okay.
And the question was is there a structural advantage to milling it versus casting it?
So with a lot of the unique features we have, we would have to do a post-machining operation to the casting. Which it comes down to a combination of cost and time, right? Because machine time for this product right here, the machine time for the book is about 80 minutes for the top.
80 minutes.
80 minutes. And for the bottom, it's actually a little bit over 100 minutes.
Wow.
Because of all of the keys that you're trying to do in there. There's features down here to support it.
So just to mill the case is a 3-hour process for every single surface book that comes off the line.
Yes. Three hours of CNC time that goes into it.
Amazing.
Yeah.
Absolutely amazing. Cool. Awesome. Ready to roll?
Cool.
I could talk all day about this.
Is that
stuff,
fun?
but apparently we need to keep going.
Yeah.
Right.
Our mechanical engineering team, I believe, is one of the best on the planet. We're lucky to have them. They kill it. You have to kill it.
What's your next?
There's a couple of things. The nameplate's ready, and they're going to form it. You just want to see how the press works?
Yeah,
Form
let's do it.
That'd be cool. And then I want you to meet Caitlin and talk about the design iteration process. I think am I coming this way?
What is that before we move?
These are CNC bits, if you will. These are all the different parts that we can put in those machines that you just saw to get to the different details that we want to get to. I don't know the exact number of how many different options we have, but you could tell we have about 1,000 different ways that we can cut into our parts. Yeah, these are cool, right? These are right out of Star Wars. I mean, they're very cool. They're very cool. They're very dangerous. They're very real. You don't want to touch them. It's not.
Yeah. You got your hand that far from
Yeah.
whatever that one was when you made that gesture.
Yeah, I don't know how many rules I just broke, but I don't think we're supposed to be over. Where am I going, Bill? Where's the press?
Cone press here.
Oh, we go to the cone press.
Just over here.
It's kind of cool. So this is a cone press where we're able to press metals and so forth. So when you think about shielding for some of our LTE products or RF products, you basically can go ahead and press your shields to get the better signals. I think we're going to make a nameplate out of this right now.
Yep. So this is what we just cut on the water jet. Now we're going to bend it up.
That's a cool name, by the way, Larry. I got to hand it to you. All right. So you want to just explain what you're doing right now?
Yep. So right now I'm holding the pedal down. It's going to start pressing this down with 6 tons of force on our stainless steel right here. So it'll stop once we get right up to the top. Release. And there's our nameplate. So it'll sit right on the desk just like that.
That's a good finish too. Well done. I think there's some blemishes, Larry, but I think you'll appreciate it when you get it. I think it's kind of cool.
Yeah.
I don't even have one of these. I mean, can you guys make me one? What the heck? How do I order one of those?
Once you just said you're not going to do my kitchen, at least you can just make me a nameplate.
All right,
right. Well, congratulations, Larry. We'll get that out to you tomorrow.
We get a couple of questions on. There was a bunch of questions on future products that I'm seeing on the stream that I just checked out while you were talking to Robin. We're not addressing future products. I know everybody wants that. I'm not unclear. There's a time and a place for anything future. It's not this stream today, but I'm glad you want products. I'm glad you're asking about them. Not today, but thank you for putting it out there. The other thing that we get asked is, and I saw a couple of parts in the stream. This is actually near and dear to my heart. I want to address it. Like, how do we listen to customer feedback? How do we know in our design process if we're doing the right things, wrong things, and so forth? Like, sure, a lot of it at the beginning of Surface was really difficult because we were hidden. And from the world, nobody knew what we were working on. Even other products like HoloLens, where nobody knew what we were working on. And we had to start from this place of secrecy that was almost exhausting because you're relying on gut, you're relying on instinct, and you're relying on yourselves. And sometimes you can get into a group think and a think tank that not always is progressing the way you want. Now, things have changed so much where now we have this balance of creating what we think would be the right next generation of technology and products, but then feeding in our customer feedback. This is a big deal for us. And from our user research, from the studies and tests that we do, and as we iterate, and when I was mentioning that process earlier, as Ralph and his team get to a 0.8 ID model, that is also the 0.8 definition of the experience, the definition of what the software experience load will be on there, how that thing comes together in a seamless way. All that then is iterated through our customers as well. Now, obviously, we do it in a very concrete, secret way. We don't do it in ways where we're able to reveal who's doing it or who's testing it, but it is about getting that feedback. And the other great thing we have right now is we have this feedback cycle that's happening on our current product line. Yeah, we know we have issues here, we have great things that people like over here. We're able to take all that and constructively make these products better, even the products in market. We continuously do updates, we hear the feedback, we make the tweaks in here, and we give people what they are asking for. It's so important. Like, we're not doing this for ourselves. People that make these products love them because people are using them. They don't love them because they made them. They love them because people are putting their hands and passion on them, and it's that same hands and passion that goes into making them. And I think that's what this whole cycle is about. The more we hear from our customers, the more beautiful we want to make these products for them. And that's what we do it for. We're not doing it for ourselves. We're not doing it for these machines. We're not doing it for this room. We're not doing it because design thinks their designs are cool. We're doing it because when people use them, we want them to love them. So that feedback's an important part of the process. That said, part of that iteration and that learning comes from stuff that doesn't always make that much sense. Like, Tom's listening, he's done a few stories on this, but I think we're going to walk all of you through with Kate how we thought about, I think, Surface Book, or maybe even another product, from the beginning to the end, how Kate took the feedback, how we looked at designing that product from end to end with all the details. You guys want to do that really quick?
Absolutely. I think you made a really good point about the love of the product and the feedback. Guys, whether you're a fan, whether you're just a Surface nerd, whether you're on Expert Zone, that real-time feedback, that makes it to the designers. Yeah. It makes it to the marketers, it makes it to the PR team, it makes it to the designers. If you send me feedback, I can get that feedback to him.
For sure. Like, this
like
is
he wants to know, the team wants to know, so keep it coming.
We read every tweet, every mail, we absorb it, we hear it. I mean, it makes us better. Like, this is what we're doing. And so this is one of these things where it's so near and dear to me. Get the feedback out there, keep pushing it. Don't make it always punishing. That's not always the best thing. Bring it both ways, but I think it's one of these things where to grow, and when Satya talks about a growth mindset, that's what it's all about. Like, where do we grow? How do we get better? And as a world, how do we evolve? This is part of that.
Exactly right. Yeah. And this is why we talk a lot about on our team about product love and falling in love with our products. And I think the ultimate test for me is if I got fired from Microsoft today, which may or may not happen based on what happens in this live stream, and I got a new job, what PC would I go buy? I'm like, this is the PC that I would go buy.
That's it.
Because I love it.
So.
Yeah. All right. So what's next?
We're going to go see Robin. Robin's one of our designers. You met Ralph earlier, who's with us still. There's Ralph, who's just hanging out. We're just chilling. He'll correct me if I say something wrong. But we have Caitlin here. She's one of our top designers here as part of the entire devices group. So it's not just Surface, but you think about all the other products that we're making. And so we thought that if it would be okay, we'd have Caitlin just walk you through some of the way she thinks about it, how we iterated from the primitive into the complicated, and she can walk you through some of our design principles.
Yeah, totally. Hi. Okay, so this is just a small selection of what we have. Like, we have so many models, we could sell so many tables, but these are some of our favorites. So These are a couple of the original ones, and this we picked up from a shop. One of our other designers picked up from a shop in Paris, and we loved this folder that kind of created this folio shape. And from there, we started figuring out how to prototype ways to make this hinge roll out in a similar way. And the cool thing about that is it actually balanced out the weight. It distributed it better, so their center of gravity was pushed forward. So our base elongates, and it saved us actually a lot of weight on the bottom. Because Robin probably talked about the weight and that being a huge part of, we want to keep it super light, because if it was a normal detachable laptop, we'd have to add a lot of excess weight in the bottom.
It's really interesting. I think that's something that probably I know it got lost on me until I started using the device. Like when I first saw the hinge and that gap, I was one of those people at the time, I was like, I don't get the gap.
Right.
And then I put it on a table and I opened it up and I went, oh,
Yeah.
got it.
Yeah.
It makes total sense. It really is one of those things I think you have to touch to understand, but the thinking behind it's really interesting.
Yeah, totally. So it was really cool because it solved one problem of the weight, but then simultaneously we had to figure out how to detach the top using a mechanism on the inside. And so this was this first prototype that we made of the muscle wire detaching, and we made a little window, and it was like this total magic moment where you can actually see it shrink, and then you just pull it off the top, which is super cool. So in parallel, we actually had to do both of those things at the same time, because you can't have the detachable thing without the actual detach mechanism. So it was kind of a crazy roller coaster of a process, but it was a lot of fun. So yeah, you can see. I mean, we did a lot of like zoomed in, tons of like close-up work.
This is what I love. Can you show the model? Because I was playing with this earlier when I came in to just take a look around, and like when you see it at that size and this scale, you get a better understanding of how strong that connection point really is and how it actually works.
And how it just it won't come off until you release this. This thread right here acts as the muscle wire that kind of shrinks when you add the electric current to it when you press the detach button. And so when it shrinks, it releases the lever and then releases it from the thing actually down below. So it's super strong. It's a really strong mechanism. Like you cannot detach it until you hit that button.
Good question off the stream, and you may or may not know the answer to it. How many iterations did you go through to get to not just a working model, but the one you're like, that's the one, that's secure enough? I mean, because I know I've done the demo in front of rooms of people where I grab the actual tablet part and I shake it like crazy, which is probably not the recommended use. Clipboard. Sorry. I'm sorry. See, and I said I might get fired, and here it is. There's the moment. There's the moment.
So many. So we're not lying when we say we could fill like an entire room full of prototypes. I mean, we went through so many options, and the muscle wire was just one of many. We didn't land on it until we kind of had this like magic moment when we saw it work, and it was like, that's it. We have to do it. So
the cool thing about this process is it's really celebrated within the team. It's not only industrial designers but model makers and engineers. They come to this space and then they work together, as one team to find the solution. So it's not just confined to the industrial designers make something and then someone else needs to make it into something else. It's like people coming together in this space and then working together.
That's beautiful.
Yeah.
I mean, it's really amazing to see it go from that to that.
Yeah,
right?
that's right.
And if you take a look at those two next to each other, you can really still see the heritage, which is pretty amazing.
Right. And then there's an icon that lives, that we picked up, and then we find out that there's a second use for it. And it took so much time to make this icon actually live in the real product. It's beautiful.
Cool. Thank you so much.
Yeah,
thanks for showing us. Appreciate it.
Of
All right, boss, where to?
All right, here's what we have. We have a couple of options. One, they're painting the rose quartz Xbox One controller right now. So we got that done.
Excellent.
Looks cool. They brought me a color sample. Check it out. I don't know who picked the rose quartz color, but that's the color you asked for. So we were able to mix it and get it. Hopefully you can confirm that that's the color you were looking for. It's a beautiful color. I'm going to give it to Kate. If that's okay with you. And just have Kate absorb this color because I think it's gorgeous. And I think maybe it'd be interesting to see the Human Factors Lab, where we start thinking a little bit more about people and the physicality of everything, from HoloLens to band to any product that we're building that you get to put your hands on, feel, see, and so forth. What do you think of that? Is that cool? It's a little bit of a long walk.
It's okay. Well, it gives us a chance to do some random acts of kindness. Give away some free stuff.
Well, you do that, and we'll.
You're buying.
I'm sure. I'm sure. Once we get that rose quartz controller out here, we'll show you what it looks like as well. So we're just going to walk down through the lab. We're back through our original doors. So in the building, on top of the, you can do your random stuff, but just to give you some flavor, on top of just the prototyping center, we also have our industrial design lab in this building, which we will not take you in today. We have a lot of the EE labs, the thermal labs, Stevie Batish and his entire team live in this building. This is where they do their magic and science, where they're able to bring the pen technology that we have and other technologies into the product, and some of the beauty of the screens that you see and all those rewards we were lucky enough to win. They basically come from the underpinnings of what Stevie puts together. His lab is also in here, and you can kind of see the walls. You can see how we just made this a little bit more of an industrial look. Cleaner today than usual. Looks a little, usually it's not this clean in the past. I've seen it worse, but maybe it's because we're doing this feed and then everybody got it ready. Look here, here's Stevie. Check it out. What are the odds? Hey, Stevie. You want to walk with us?
Yeah, sure. What are you guys doing?
We're going to go to the human factor.
Okay.
So this is Stevie Batish, so our chief scientist on all Microsoft devices, which is kind of cool. Stevie Ben. We're going to walk over to the human factors
We've
lab.
got 1,800 people on our Facebook live stream right now.
Hey, what's up, 1,800 people?
If you guys have a specific question for Stevie, that would be great. That way I can stop talking and Stevie can start talking. Yeah.
They can talk back.
They write back.
Yeah. They don't really talk back. They write back.
Okay, they write back.
We don't really see it. It's really
Getting a
odd.
lot of love for the elemental room names.
Yep.
Yeah, I love it. You guys caught that. Yeah, whoever that is. Like, there was a question earlier on the stream, like, hey, how do I get to work here? Like, come on, we're hiring.
Yeah,
Get
so
your
Eric,
resumes
you
in and
caught
let's have
that?
those conversations.
You've got a 3-month Xbox Live Gold card. That's our first random act of kindness. So good catch.
Wow. What is this random act of kindness thing? I like
I mean, as much of a draw as you and I are, like, people want free stuff. Too.
Yeah. Do you want to get us over there, Ralphie? Listen. Beautiful. Okay.
Come on in.
So here's the Human Factors Lab. We're going to walk you in here. You can think we do a lot of testing when it comes to, we said, hey, how do we get customer feedback when we iterate through products? When we get to the details of when we wanted to create something, when it comes to comfort on our keyboards, on our mice, on our Surface, on our HoloLens, on band, like how do we push it to really understand the trade-offs in technology and comfort that we bring together? Would you introduce yourself, Rob?
Yep, Mike Bohan. I'm the director of Human Factors
So,
Engineering.
Mr. Bohan does a ton in this room, in this space. We thought it'd be fun to show you a little bit of what that is. I'm going to turn you over to Michael, and he'll just give you some details.
Yeah, so like Panos was saying, we're designing products that are comfortable for all kinds of people all over the world. One of the ways that we do that is we measure people. We measure people and we build models of humans that we can design around and test to. As you can see, these are some of the instruments we use. But we also use more sophisticated instruments, one of which I'd like to show you right now. Designed to be built to scan human heads. And this was so we could build a real understanding of human head shape and size. We can build products like HoloLens to be comfortable for the broad range of population. Would you like to try it?
I did, yeah. And when we were in here, just a full disclosure, when we were in here last week, some of you saw the picture that I posted of this. This thing's amazing. But you said that I can hop in there, you can take a new picture of it.
That's right.
Almost instant.
That's right. These cameras, with multiple different angles, will fire simultaneously, so it's a really rich view of the person's head. And it's really instantaneous. Why don't you get in there and we can show it?
All right, let's try it.
Tim, you want to come over and run this, please? Thank you.
Alright, I'm gonna do the necklace where you get distance. There you go. Then have you spin around and face the camera on this back wall here with that red ball on top of it. Try and sit up as straight as possible and just listen for my voice. I'm gonna give you some direction as to how to lean. We'll get you as centered as possible, and all those guys will take a picture at one time. And you're just gonna hear all those camera switch modes again here. And just stay as perfectly still as you can. And
Got rid of
here we
him.
go.
Ben, let's hope we get you back. It's like a magic trick. Oh no, he's still
And
there.
just like that, we're all done.
Still here.
All
So
right.
that's it. It's as fast as that.
It's amazing.
Then we can come over here and see the process of how we go from taking those pictures to creating the models. So here are the individual pictures from all the different cameras. Make sure we have complete overlap.
So theoretically, you can even find a good angle for me.
That's right. I think we might be able to find it. We'll see. So then it goes through a process of photogrammetry that puts all these images together.
And we come out with a model that looks like this. Whoop. Whoa.
Now, I always look mad. Now look at that picture. I always look mad.
So we get like really incredible level of detail and accuracy, which really helps us take our product to
Very amazing.
right. And then further down the process, these are sort of the CAD models that we use.
Yes, sir.
You guys doing today?
think so.
We're almost
Are we
right
just
out of time.
about out of time?
Yeah, we are.
Man, that hour goes fast.
So I want to Kate, Robin, just thanks for joining us today. I hope you enjoyed the behind the scene looks. I thought you got everything you guys wanted. Hopefully out of today that was just on the surface, if you will. Anything you need from us, make sure you tweet it. Make sure you post out to us. Let us know if you have any extra questions. I'm going to follow up with Ben. There's a bunch of things in the live stream I know we didn't get to. I got to get going.
But that means we'll do another one.
Let's just jump on it and maybe we can find
Put
a
you on the
session where
spot.
we can answer a bunch of questions.
All right.
All right.
Thank
I hope
you
you
so
really
much.
enjoyed it, and thank you so much for joining us today.